So the lectures from now on are advanced topics, and one of them is internet connected drones. So that's what we'll be covering today. And I really should change the lecture topic to air traffic control, because that's one of the main advantages of having your drone on the internet. And we may not need the whole hour and a half for this. We'll see how it goes. So the very first, so you all have built your drones. They're connected to your radio controller. You're going to eventually have them connected to your Raspberry Pi, and you'll have an IP address. And that's all optional. But the question is, what is the method to integrate drones into the national airspace system? And that's what I'm going to be talking about today. There needs to be some method of air traffic control for drones. And it's pretty clear that it's going to be internet connectivity that's going to allow the air traffic control for drones to occur. Now, I don't know for sure. So you are witnessing the birth of an industry happening in front of your eyes in real time. And it's not going to get finished by tomorrow morning. It's not even going to get done by the time you graduate from my class. I'll tell you the state of the art at this moment, where the industry has been and where it's going. And it's not determined yet. There are a lot of decisions that still have to be made. And the bottom line is drones have a technological advantage that's not really being exploited, because as of now, they're only allowed to be used when they're within visual line of sight. And it's only one drone per pilot. So by law, one pilot can't control more than one drone. And by law, one pilot can't fly a drone far away without very, very special exemptions. So that's obviously restrictive, and that's why the drone industry has been small so far. And and why is that? Why do you think it is? Yes?
Many limitations.
Well, why do you think there are limitations? Safety, because you don't want a drone to collide with a manned aircraft and cause an accident or death. And US has the safest airspace in the world. It's also very conservative. So they're going very slow. So I'll be walking you through today where that process is, but it's all going to involve some sort of internet connected drones. And let me go back a step before we even get into that. So let's forget about drones for a moment. What about manned aviation? How do they do their air traffic control? Do you people know that? How is it that before drones, airplanes were prevented from colliding with each other? Yes.
Radar.
Radar?
I think systems that detect, send set off an alarm when they get too close to each other.
Collision avoidance? Yes. Yes.
As well as people that's looking at the airspace constantly and telling the pilots to avoid each other, I think.
So air traffic controllers, yeah. So there was a famous collision between two airliners over the Grand Canyon. I think it was in the 50s or 60s. And they were at high altitude, and that was a wake-up call for the aviation industry, that there needs to be some way of separating aircraft, or they're going to crash into each other maybe. So the easiest way is see and avoid. But to see an airplane that's going fast, you have to have very good eyes. And even if you have really good eyes, you may not see it in time because they're going very fast. So radar is one method that you can use. So you have a ground-based radar that bounces microwaves off of the skin of the airplane, and that determines the distance to the airplane. Unfortunately, it does not determine the altitude to the airplane. It only determines the distance because it's a time of flight measurement. So then the next step was airplanes were required to have a transponder that if they got pinged by radar, they would broadcast their altitude back to the local radar through some broadcast mechanism. And so that allowed the air traffic controllers to have a picture of the radar screen, and there'd be blips on the radar where all the airplanes were, and then there'd be an altitude transponder on each airplane. So you have to have a network of radars all around the country. Otherwise, it's not going to work. If you're out in the middle of nowhere, there's no coverage. And so another phase was, so that's a centralized control system. The next phase is a local, decentralized, locally hosted control system, and it's called TCAS, collision, I don't know what T means, but CAS is collision avoidance system. And if your own airplane has a radar on it, it might bounce the radar off of another airplane and see it. If you have an airplane, if you have a big enough airplane that you can have a radar, then your airplane has its own radar on board. So then if your plane sees another plane, the computer can say collision imminent, go left or go right. And there's actually a program, an algorithm that's been used and shown to be very reliable and prevented many accidents, which gives both pilots that are on a collision course directions. One pilot is told to rise, one pilot is told to climb. If they both are told to rise, then they're still going to possibly collide. So that's very successful. So now in the 80s, the FAA required that airplanes actively transmit their location and not passively just respond to, reflect microwaves off their skin. And that is called ADS-B. ADS-B. So that's for aviation. Automatic Dependent Surveillance Broadcast. And that's a beacon that airplanes are required to have on board that emits their lat, lon, altitude, and heading and whatnot. So not every airplane is required to have that at this junction. If you're in controlled airspace, that means near an airport, an airplane is required to have that. However, if an airplane is out of controlled airspace away from an airport, it's not required to emit an ADS-B signal. So it could be radio silent by law. Additionally, police and military are allowed exemptions. So even if they're near an airport, they're allowed to be radio silent. So that's the state of the art at the moment. It's called ADS-B. It's a broadcast identifier. And it's about a kilowatt of radio energy in about a millisecond pulse. So there's no safety issue, but it can have a range of 100 kilometers. So I have a lot of senior design teams that get SDRs and they receive that signal. It's at around 1 gigahertz and it's freely available. And then you can plot the location on a map. And there's a lot of people that have Raspberry Pis with SDRs that feed it into a few centralized databases, and those centralized databases then plot the location of the aircraft on the map. So that's what's shown here. This is one website. It's my personal favorite. So here we are, and here's a plane flying right over us. So if we click on the plane, it gives you the information that the ADS-B is broadcasting. And so all planes that are civilian that don't have exemptions are required to emit that at least once a second. And then that's what air traffic control mostly uses to manage the airplanes. Then they talk to them on the radio. Actually, it's pretty amazing. Your generation probably finds this very archaic, and I do also. Is they're talking to them by phone. They're talking to them on the radio, telling them go left, go right, go up, go down. So that's still the way it's done in the United States and around the world. So here's one coming into land at John Waite. You can see their pattern. So this is the picture that the air traffic controllers have at John Waite. So even airplanes are not internet connected by law and by default. And that probably will change. I think the airlines probably have internet connectivity on them, but that's not for air traffic control. It's for the airline to communicate with the pilot about the airline business. The actual control is done by a radio phone call, go left, go right, clear land, clear takeoff, a person talking to on the phone, on the radio. So even airplanes aren't internet connected. So in that existing, okay, so where is that going? Probably airplanes will be internet connected eventually, and there'll be some internet algorithm that improves air traffic control, spacing, and whatnot. And actually, this is a big improvement because it used to be that they had to fly to certain waypoints, all of them, and they couldn't deviate. So this is already an improvement, but it needs to be improved more even before the era of drones. And I guess probably it will be where there'll be some integrated air traffic control system where a computer tells the pilot where to go instead of a human telling the pilot where to go. However, that's not the way it is now, and as you can imagine, that needs to be done very carefully. Okay, and the US government isn't always efficient. I mean, the government is shut down now. So there's also the practical reality of it takes time to implement new technologies. So manned aviation is 100 years old, and what you're witnessing in your lifetime is unmanned aviation. Is how do we integrate unmanned aviation into that system? So what do you think would be a good way to integrate drones into that system? You tell me, because you're probably making the decisions if you stay in the industry. Right now, the answer is don't. You don't let them go past this line of sight of a pilot. If a pilot of a drone sees an airplane, he is required to avoid that airplane by manually flying. So what do you think the FAA should do to integrate drones? Silence, which, okay, you must have some ideas, but there is no killer answer at the moment. So we'll leave it at silence and talk about ideas that have been proposed by other people if you don't want to propose any. But the answer is not obvious and not clear. Okay, so let's talk about what has happened and what is happening, and then we can speculate on what should happen and what will happen. So the very first step that the FAA claims to have taken, well, is remote ID. Now, as I mentioned, you're witnessing the birth of the industry. There is no answer to all these questions because the technology isn't there, and that needs to be developed and demonstrated. So as the technology development develops, the industry will broaden, and eventually there will be, let's say, probably more unmanned aircraft in the skies than there are manned. There's already more unmanned registered pilots than there are manned registered pilots. I showed that on day one. There's over 1 million registered drone pilots in the US, and there's less than 1 million registered manned aviation pilots. And a lot of drone pilots don't even register. And that's now. So it's already more drones than manned airplanes in the sky, average over a year, but they're not integrated. So the first step that the FAA is trying to take and claim, well, yeah. And then the other thing is when a new industry comes about, it doesn't always evolve linearly and logically. Things happen, money's involved, laws are involved, existing technologies are involved, new technologies displace them. So it's a messy process. It's not always a clean process. And you're going to see that in some of my slides, and you'll see that after you take my class, as you see the industry evolve. So the first thing the FAA did, so now let's get down to business, was to require a drone transponder, not really transponder, a transmitter. It transmits its lat and long. It's called remote ID. And that is now required by law for any drone in the United States weighing over 250 grams, with only a few special exceptions. So I've tried to keep your drones under 250 grams, so you're not required to do it. But if it goes above 250, you're required to do it. So the broadcast is the signal is the lat long and altitude and speed of the drone, and that's required to be broadcast now by the FAA, except for a few special conditions. That rule came out about 3-4 years ago, and they had actually proposed requiring the drone to be connected to the ground. And one of their proposed ideas was that the drone would have to connect to the internet and report its location before it would be allowed to take off. And that idea is still being proposed by some people in the US government. And so I am not going to give you my political opinion on that, but I can tell you my engineering opinion. I think it's a horrible idea because look at what happened to the internet last week. You have one centralized point of failure everybody was relying on Amazon East. And as soon as that went down, the entire internet went down. So I think it's an absolutely horrible idea to have safety related machines relied on a centralized computer to have permission to operate. I think it's a horrible engineering idea. But that may still come to pass because it is true that engineering systems can be very reliable. The internet is very reliable, and it only goes down once every 5 years like it did last week. But you were in my class, you saw we couldn't even do Canvas. So my personal opinion is centralized systems from an engineering point of view with a single point of failure are a very bad idea from an engineering point of view. So we'll see if that happens. However, because the internet connection technology wasn't there, that did not go through. That rule did not get put into place. So as of today, it's only direct broadcast. So the rule requires a specific standard. And now we're going to get in, and we're getting into advanced topics. And you're learning, like I said, when you see the birth of an industry, you see how new technologies come into being, not just the technical part, but how it interacts with everything in society: legal, financial, moral, ethical, safety, political, geopolitical, regional. So these technologies that are worldwide affect a lot of people, and a lot of people weigh in on them. So one of the ways in electrical engineering and computer science that new technologies get implemented and eventually become regulated is through standards bodies. And the IEEE is one standards body, and the ASTM is another standards body. ASTM stands for American something standards technology something. And these are standards committees of experts in industry and some academia, although it's mostly industry, that get together and agree on a standard. So the internet is similar to that, and Wi-Fi is definitely like that. So when Wi-Fi first came out, there were a couple competing standards, but the industry participants got together and said, okay, we're going to agree on a specific Wi-Fi protocol. Because if they disagreed, there'd be competing Wi-Fi protocols, and then one Wi-Fi system wouldn't be compatible with another Wi-Fi system. So to avoid that, typically industry will come together and agree on a standard, and they publish that standard. And the IEEE is one organization that does that, and the ASTM is another organization that does that. Once that standard is published, then a lot of times the government will come in and use that standard and say, okay, we're going to regulate anyone doing Wi-Fi has to obey that standard. So that's what they did with drones. They said, okay, the standard has been developed for remote ID. Now we, the FAA, are going to come in and require that you use that broadcast standard by law. So they call it sausage making. And it's important for you to know that when the government makes rules about technology, it's not like there's a whole bunch of smart people sitting in an office in Washington, D.C., just thinking up those rules off the top of their head. They go out and participate intimately with industry, and they also aren't, they may be smart, but they may not have the industry experience in that particular domain. So a lot of times they rely on these standards committees to give them recommendations on technical matters that they don't have the domain expertise in. Okay, so that's what happened to remote ID. And the standard is called F3411-22A, standard specification for remote ID and tracking. And the goal, so the proposed one was this network, which has not been required yet, but the broadcast one is required now. And the idea is shown here from that standard. And here's the first paragraph of that standard. The scope specification covers the performance requirements for remote ID of unmanned aircraft systems. Remote ID allows governmental and civil aviation identification for UAS for safety, security, and compliance purposes. The objective is to increase UAS remote pilot accountability by removing anonymity while preserving operational privacy for remote pilots, businesses, and their customers. Remote ID is an enabler of operations, enhanced operations such as beyond visual line of sight, BV loss operations, as well as operations over people. So that's their statement, and that's why they developed the standard. So each broadcast, okay, so the broadcast is actually Wi-Fi and Bluetooth. So they made a decision that it has to be on Wi-Fi or Bluetooth. So each broadcast message, which comes once a second, has these message elements in it. And it's either Wi-Fi or Bluetooth. So what's the range of Wi-Fi? It's only about 100 meters. Bluetooth, only a couple hundred meters. So it's really not a long range control or identification system. So these are the fields that are broadcasting remote ID. Now, within remote ID, there's some variations. First of all, like I said, police and military typically can get exemptions from the requirement to broadcast remote ID. It's done on a case-by-case basis. There are sites within the United States, about 1,000 of them that are basically usually model airplane clubs where they get exemption at that particular location. Those are called FRIA, federally recognized identification areas. There's a few in Southern California at the model airplane clubs. Out at Irvine Lake is a remote ID exemption, and so on. So there are a few thousand of those in the US. And then if it's required, then there are two kinds. There's standard and broadcast. So broadcast is for do-it-yourself people and also grandfathers in old drones. And that's where you put a module on there. You stick the module to the drone. And you can buy these modules for under about $50 now. They only weigh about 10 grams. And they have a little GPS and a little battery and a little microcontroller, of course, and a little Bluetooth and Wi-Fi radio. And it transmits the Wi-Fi over Wi-Fi or Bluetooth, the lat long with remote ID standard. So that's called broadcast remote ID. And then standard remote ID is for off-the-shelf systems that are not homemade. And that one requires, like DJI, for example, and that requires the standard to be integrated into the drone if you sell the drone as a whole system. And it's also required to broadcast the location of the operator, the pilot. So that's remote ID. And that's a start toward air traffic control, but because the short range, it's not going to solve all the problems. Additionally, it's required by law to register that serial number with the FAA so that if they find a drone flying in the airspace and they'd get the remote ID serial number, that they can look up the name of the operator. So that's the law. They call it a license plate in the sky. And I'm not going to give you my personal opinion, but I'll tell you this was very controversial when it came out, and it continues to be somewhat controversial. And so was ADS-B for airplanes. ADS-B for airplanes was controversial because the manned aviation pilots that had little Cessnas didn't want to pay the money to upgrade their aircraft. And they still don't want the privacy implications. They don't want to be tracked. And Elon Musk has a plane that gets tracked. And there's an undergrad that tracks him. And Elon Musk is very unhappy about it. So even billionaires sometimes get tracked because the requirement. So there's a lot going on. It's not just technology. However, we don't want airplanes colliding with each other. And did I tell you about the two known collisions? Okay, there have been two known collisions between drones and manned aircraft. One in the US, one in New York City about 4 years ago. Somebody was flying a DJI and he flew about a mile away and it collided with a Black Hawk helicopter. It hit the helicopter rotor. It didn't do any major damage. The helicopter landed safely, and they were able to take the piece of the DJI and find the serial number and track down the operator and punish him appropriately, because that's illegal. And also, obviously, it was unsafe because he collided with a helicopter. The other one was last year. There were fires up above Hollywood, huge fires, and firefighters are very careful about airspace control. Once they take over the airspace control, they're super, super conservative because they fly low and fast, dangerous missions. So they are very conservative. Anyways, a pilot who was a PhD in math from Berkeley took off from Santa Monica, flew all the way to the San Gabriel Mountains and wanted to get pictures of the fire and I don't know what. And then he collided with one of the super scoopers that dumps water on the fire, and it punched a little hole in the wing. The airplane landed fine, but he was fined and I think faces some jail time. So there have been some collisions. It's actually, if you look at the numbers, drone aviation is the safest form of aviation by far. I'm not going to go through the safety analysis. If somebody wants me to, I can give a side lecture on that. But hour for hour, by far, drone is by far the safest form of aviation ever invented by mankind by a country mile. But if there are going to be lots of them in the airspace and they're going to be near airplanes, then there needs to be some system to integrate them. Okay, so these are the technical specifications for the broadcast. There's lots of good senior design projects for that. Next week's lecture, I'm going to have a demo. I'm going to bring in a couple of remote ID modules and drones, and we'll do a demo remote ID receive, and we'll do a practical demo on Tuesday. Now, drones emit signals. As you know, you have to send a radio signal to your drone, and if you have telemetry enabled, it's sending a signal back down. And DJI is the biggest market share, so they actually sell a radio that will track all the DJI radio signals from all the DJI drones and plot it on the map. And these are available to the government and airports. And most airports have these installed. So if you take off a DJI drone anywhere around an airport, probably put it on a map somewhere. Notify and fly is another proposed way of having remote ID. So you just say, I'm going to fly here at this time, and then that part of the airspace is reserved for you. So the next step in the progression is to enable drones to fly beyond visual line of sight. And again, the technology isn't really there yet for broad integration. So in 2000, but it could be with the right set of rules and the right parameters. So as of this moment, there's a lot of discussion in the federal government about who owns the airspace, who has the right of way, and that discussion has not been resolved. As of now, drones have to be flown within visual line of sight, and they can't be flown above 400 feet. And if there's any manned aircraft anywhere near, the drone has to give way. So as of now, manned aviation owns the airspace, but that's very limiting for drones. So the FAA was tasked by Congress, and Congress was pressured by industry to develop a set of rules that would allow drones to fly beyond visual line of sight. And they've had years and years, all sorts of committees have written hundreds of pages of reports. They've done tests, they've done studies, and they've had discussions. And in 2025, the FAA developed the rules and they released them on August 6th of 2025. Now in the United States, the Congress is the body that passes laws. The executive branch is not allowed to pass laws. So if there's going to be a law, it has to be passed by Congress. A rule is an interpretation of the law. Now, I'm not a lawyer, so please don't take this as legal advice, but a rule is allowed to be enacted by the executive branch. However, it's required to have 60 days of public comment before the rule is finalized. So if the executive branch creates a significant rule, they're required to publish a draft of the rule. The public is allowed to comment on it for 60 days, and then they have to take those comments into account before they finalize the rule. The technical term is they promulgate the rule. That's the only time you'll ever hear that word. I've never heard it in any other context. They make a rule. It's a fancy word, they make a rule. So the FAA came up with a rule in August, and you missed the deadline to comment because 60 days is up. And then this is a draft of the rule, and it's 180 pages. So it's a very complicated rule. Let me see if I can pull it up. I think I have it on my disk here. And you can pull it up. Here it is. Here's the rule. So the draft rule came out in the Federal Register, and you can see over here, it's 180 pages. So I'm not going to read the whole thing, and you don't have to be an expert, but I will tell you some of the highlights. Let's see, I'm going to. I preserve. And you might be bored because this doesn't apply to you, and it's not going to for a long time. So if you don't want to watch the rest of the lecture, I won't feel offended. This is the direction the industry is going. I'm giving you a snapshot. But if you're interested, join my senior design teams and create a demo air traffic control. And I know Levon is doing it, and I'm going to talk a little bit more about that in the rest of today's lecture, is to create a prototype air traffic control system. We have 43 drones. They're all going to be on the internet. On Tuesday, I'll show you how to get it on the internet. We'll do a live demo. And Shing, you're fired because my drone's going to be in the office, okay? I'm going to have my drone in the office. So you will be here and we'll have the drone in the office. We'll connect to it over the internet. And we probably won't fly it because I don't have that set up yet, but we'll get into that on Tuesday. So if we have 43 of us, we can do a demo air traffic control system. Anyways, so here's the rules. And you can see, for example, they're proposing to have different classes of aircraft drones and allow them up to 1,300 pounds. So it's a serious proposal for a broad adoption of a new industry. So the public comment period closed about a month ago, and now the government shut down. So nothing's happening until the government opens again. When the government opens again, they probably will take about a year to read all the comments. And then they will consider those comments and then revise the rules and issue a final rule. So this is a summary. This action proposes performance-based regulations to enable the design and operation of unmanned aircraft systems at low altitude beyond visual line of sight for third parties, including U.S. traffic management, UTM, that support these operations. The FAA Reauthorization Act of 2024, that's Congress, directs the development of this proposed rule. So Congress instructed the FAA to do this. This proposal, and by the way, it says low altitude. So the proposal is only for below 400 feet. The proposal is not about allowing drones to go above 400 feet. So already we're restricting it, and even then it's very complicated. This proposed rule is necessary to support the integration of the unmanned aircraft systems into the national airspace system. The proposed rule is intended to provide a predictable and clear pathway for safe, routine, and scalable U.S. operations that include package delivery, agriculture, aerial surveying, civic interest, operations training, demonstration, recreation, and flight testing. Scalable means millions, in case you didn't figure that out yet. TSA proposed to make complementary changes, so there's security aspects as well. So you can imagine there's a lot of issues that go into that, and one of the biggest ones is right of way. And the Aviation and Rulemaking Committee, one of the committees recommended all the way back in 22 that drones get right of way over manned aircraft under 400 feet. And now that's a very big controversy because helicopter pilots really don't want to have to avoid drones because they fly routinely below 400 feet. And that has not been resolved. Balloon pilots are even more concerned because they can't maneuver the balloons. So the question of who owns the airspace, and I would say there should be some technology to improve that. It seems to me like internet connectivity would be one way to improve it, but that's just me. So there's lots more about the beyond visual line of sight. I should probably just show you for fun the comments. It's called Notice of Public Rulemaking, NPRM. And the public is allowed to put comments in. And there have been 3,000 comments. They're all public. And so let's find, bless you, there's a comment. A lot of them are from individuals. Here's one from Quantum Helicopters. Okay, the helicopters have nothing to do with quantum mechanics, but okay, it's a cool name. It says, I'm writing to formally oppose the proposed right-of-way for Part 108, which would grant UAS conditional right-of-way, particularly shielded. So that issue has not been decided yet, and the government will go back in a smoke-filled room behind closed doors and take all these comments into account and try to do its best job to fairly regulate the airspace system. They'll always err on the side of safety, and then everything else will be a secondary consideration. So you're welcome to read any of those comments. Okay, so let's go back to the slideshow. Now, long term, the best solution is internet connected drones with some sort of an air traffic control system. So there is a technology being developed. And Levon asked me about this yesterday, and so I'm going to give some information about it. Like I said, when the government regulates new industries, it doesn't just sit in a room and just think up the regulations off the top of its head. It interacts with industry. Industry provides data, safety data by the thousands of pages. Industry pays a lot of money to do all the safety studies, typically, and prove to the government that what they want to do is safe, especially in aviation. So there's a architecture that's been developed, which is basically air traffic control for drones, but only drones. So drones would have their own air traffic control separate from manned aircraft, called UTM, Unmanned Traffic Management. And this is one picture from a publication of how it would work. You have drone operators that log into some cloud-based service provider. That cloud-based service provider then reserves the airspace at a specific position and a specific time for that drone flight so that it can fly beyond line of sight, and it allows the drones to avoid each other. And then there'll be more than one service provider, so they also have to interact with each other in a way that is safe and efficient and timely. So there's actually a standard on that from the ASTM called UTM USS Interoperability Standard. So USS is the service provider that provides the management for a subset of drones in the sky. And then the interoperability is the API standard allowing the USSs to talk to each other. So all of this has already been fairly well thought out. And Google has been one of the leaders in this. They've been putting a lot of developers on this to develop the code. I'll show you that in a few minutes here. So the idea is that you have an operator with a drone. He logs into the USS. Now they're calling it USS. Well, that's some sort of coordinator. And it has a map of all the drones in its system, and it makes sure that they don't crash into each other. And it has to interact with all the other USSs. So it's interesting because one of the comments on the BVLOS is that this is essentially developing a privatized air traffic control system for drones, because the USSs would be private companies. Whereas for manned aviation, air traffic control is public. That's the FAA. So there have been some comments on the BVLOS, and again, I'm not allowed, and I don't want to give you my political opinion, but there's a lot going on in this, and I'm not going to, and it doesn't matter. I want to educate you so you make your own decision. But there's obviously a lot going on. Even if I wanted to, there's so much to cover. I can only just skim the surface. So, but one of the big directions the industry is going is that the air traffic control is going to be done by private companies. So the company will have some cloud service, the drone will log in, the pilot will log in, they'll reserve a spot in the airspace, and then the private companies have to coordinate with each other to make sure the drones from one private company's system doesn't clash with the other private company's system. You beat me to the punch. So, yeah, so those standards are there. So you can look into it, Levon, and read it in full detail. And they tell you exactly how many seconds you need to be ahead and how much the latency should be. And that's all being developed. And it's on GitHub. So that's being developed through a consortium of companies that comes under the Linux Foundation. So we talked about Mavlink coming under the Linux Foundation. There's another foundation under the Linux Foundation called the InterUSS Platform. They come under the Linux Foundation, and that's a consortium of all the companies that want to do beyond visual line of sight. All the big aerospace, Boeing, TRW, all the integrators, Airbus, who else? The Google has a subsidiary called Google Wing that's very active. Amazon wants to do drone delivery. There's a lot of small companies that want to do drone delivery. There's a lot of companies that just want to do airspace control and air traffic control. So they're part of this consortium, and they're developing this code and demonstrating it. There's a complementary one called Global UTM Association, which also includes participants from Europe. And they have a GitHub webpage here where you can see their inter-USS platform. So it's not the USS itself. Let me go back. So this thing in blue is going to be proprietary. It's going to be a cloud-based service that provides separation between drones, but the code will be proprietary. It'll be a pay to use. But the interface is going to be public. At least that's the vision for the moment. So that interface is called InterUSS, and that is on Google. I mean, on GitHub, and you're welcome to read it. And there's a getting started, and here's a background. And it's open source, and they have some field tests. And I'd like to just go to that web page so you know. So there are a few field tests of this, which are being done, one in Dallas, one in Virginia, I think one in New York, under FAA authorization to do testing. And the one in Dallas, they have Google Wing, they have Amazon, and many other small and large companies. So they actually have a legal agreement already. It's version 2.0 already. And this is the legal agreement between the companies about how they're going to coordinate with each other. Whereas, et cetera. They define all the terms. It's 29 page. So the industry is already, it's not just starting from scratch. So they talk about data privacy, operator responsibility, joint responsibility, governance, cost and fees, ownership. And there it is. There's the elephant in the room, because these companies aren't in it for free. Access and use restriction, confidentiality. That's only page 5. And this is version 2.0 that was just released yesterday. So like I said, you're witnessing the birth of an industry in real time. So if you want to if you want to take your drones from 195 and go to Dallas and join them, you have to sign that agreement and have some lawyers. So that's where that is. And let's go to slideshow. Okay. Now, they've already done the demos a while ago, even back in before COVID. Google Wing. Wing is a subsidiary of Google that is doing drone delivery. Amazon, Kitty Hawk, Skyward, Uber, Uber. So UAS Sidekick. So that's another point that I want to make here, is that the FAA's approach has been, they call it crawl, walk, run. They crawl first and they walk when they run. And many companies have gotten investments of many hundreds of millions of dollars to develop air traffic control. And most of them have gone bankrupt because there is no need for air traffic control, because you're not allowed to fly beyond visual line of sight. Skyward is a very interesting example. And I'm not picking on them. It's not necessarily their fault. A lot of companies have fallen but I'm going to give Skyward as an interesting example because it was created by Verizon. Verizon is one of the main telecom providers. And so they started a spin-off startup company called Skyward, and their goal was to have air traffic control for drones. This is way before COVID. And I remember at CES in Las Vegas, they had the president on stage, and she flew a drone in Las Vegas while she was on stage, and in Los Angeles while she was on stage in Las Vegas, and that was supposed to revolutionize the industry, and that was before COVID. So until the FAA allows it, it's not going to be brought widespread. So that company shut down. Verizon shut it down. I don't know how many millions of dollars they invested. It's public, I'm sure. I'm sure it's more than 1 million. It probably is more than 10 million, and it just nothing happened. Yes, Levon?
A little fact is, so we were talking about Wing, they're already doing thousands of deliveries every week.
Wing is doing thousands a week
Yeah, with
Yeah.
Walmart, they partnered.
with Walmart.
Yeah,
Okay.
and the average fulfillment time is under 20 minutes.
Fulfillment time is under 20 minutes. That's the Dallas site, right?
Yeah, and they're expanding. They actually have a few more, 5 more locations they're going to expand to.
Wing is going to expand to 5 locations. Okay. So Google has a lot of money, and it can have these projects that have long-term returns, and they have the patience as investors. If you start a company without the support of a super company like Google, your investors want a return on their investment within 5 years. If you don't get them a return on their investment in 5 years, they'll shut you down. And that's what happened to a lot of startups. Google Wing is a startup that Google's patient. And Google's doing the same thing with quantum computing. Google invested in quantum computing. We talked about the Nobel Prize, and that's still not a profitable enterprise for Google. But they continue to invest heavily in quantum computing. IBM also. And they're putting hundreds of millions of dollars into quantum computing, even though they haven't seen profit on that. So Google is doing that with drone delivery. And thank you for that comment. But the FAA is requiring very specialized permissions, so it's not broadly available. Okay, that's Skyward. Some of them have survived. So one of them I just got an email from yesterday called Airspace Link. So this is a startup company that I actually like a lot. I don't know anything about the people. I just know the company's product. And they sent me an email saying, "Dear Peter Burke, please subscribe to our drone fleet management system." Okay. Well, we have 43. I guess maybe we could do a demo. I may get a beta test, but you can track all the drones, track all the pilots, track the battery state of each drone, and see if the motors are spinning, if there's a problem. So if somebody has a company that has a fleet of thousands of drones, then this Air Space Link is there and ready to partner with you and help you with fleet management and air traffic control. And that is possibly going to be a huge market. So I don't think it's a huge market now, but it could be in the future, and they're still alive. And anyways, I'm talking about them because they're a software company. They're not hardware. And come on, let me get to your website. There's the website. And I've used them for my own drones because I have an account, but I don't use it for well, I have a fleet of drones. It's not 40 like you guys, but I only fly one at a time. But I've used it to actually get airspace coverage from the FAA for special permission. So they do have a portal where I can get special permission that's not automatic. So if I'm in a 0-foot grid or near the airport, I got to get special permission. I can go through this website. And I'm on the free tier, but they have a paid tier. So that company's still around, and I hope they succeed. So those are big and small companies that are in the industry. Oops. Okay. Now let's hide presenter view. Okay. So here's a list of some of the companies that were in it as of a few years ago. So you can see all the major aerospace industries are in there, even GE, huge conglomerates, Intel. So all the companies see the future in this technology. So they're all joining in the industry effort to standardize it, demonstrate it, and then bring it to market. Now, that's just air traffic control, but what you can actually use the internet to control your drone, and that's what I call true long-range control. So not only that, it's on autonomous flight, but what if you want to change the direction? And that's another, well, I'm not going to get into that rabbit hole. So you could not only use the internet for location tracking, but you could actually use it as a remote control method. And that's what I'm going to demo next week. I'm going to have your drone in my office, and I'll fly it from here. Okay. And I think I'm going to skip that. And this has been weaponized. So you probably all heard about the Ukraine attack on Russia. And what they did is they put a bunch of small drones. Yeah. The Ukraine has basically changed the drone industry by scaling up the use and production of moderate sized drones. When I started this class, one of the reasons I designed your drones to be 4 inches is that they were cheaper. The 7 and 10-inch drones were a lot more expensive, like 2 or 3 times the cost. And after the war in Russia, Ukraine started mass producing them. And I think they're producing like millions a year. And so the cost went way down. So now the cost of a 7-inch or 10-inch is actually the same as the cost of a 4-inch. And I'm going to create a standard 7-inch and 10-inch design for all the students that want to do it. And I figured it out with the UAV Forge team. If you just take your drone and replace the motors and the propellers in the frame, everything else can be the same. Just bigger frame, bigger motors, bigger propellers. Your speed controllers can handle the current because they're 20 amps ESCs, and even the big motors don't need that much current. So all you need to do is swap the frame out, and the frame is $25. It's a piece of plastic. The motors, because partially because of the war in Ukraine, the bigger motors are cheaper now than smaller motors. And then the propellers are pretty cheap. The battery is a little bit, yeah, the battery's cheap. So it's actually about the same cost to build a 10-inch version of what you had. I don't know, do you think I should do 10-inch next year when I teach this class? I'm a little afraid for you, because that's a big drone to be doing your first drone on. But a lot of students are pushing me to have that be the standard design. Anyways, so what they did in Ukraine is they put them in trucks. They drove the trucks to Russia, and then a pilot in Ukraine logged in from the internet, opened the top of the truck, the drones flew out, and they were parked next to the airports, and they did extensive damage to the Russian bomber fleet, significant damage. And it was all done by remote control over the internet from Ukraine using the cell phone networks. And in fact, Russia has started selectively taking down, according to news reports in the public, cell phone networks in different regions of the country at certain times of the day. So you don't get cell phone service because they don't want an attack. Okay, so that's that. Now you mentioned collision avoidance. So another technology that needs to be, okay, so that's state of the art of air traffic control, centralization, and now let's talk about the decentralized options. So you also want some onboard intelligence and autonomy. And we'll talk about scripting next week in autonomous flights, but there are many proposals to have drone collision avoidance systems between drones and manned aircraft. Actually, drones and manned aircraft is easy. Technically, principle, it's easy. If you have let's go back to ADS-B. Manned aircraft transmit this ADS-B signature. So if you have an ADS-B receiver on your drone, you should be able to avoid the manned aircraft. So I think that's probably the lowest hanging technical fruit. And that's built into ArduPilot. And you can do that as a senior design project if you want. And there are manned receivers from ESP32 chip, which we talked about last week. And they receive the ADS-B signal from, well, I guess that's not ADS-B, that's a different frequency. Sorry, I'm wrong. You'd have to use an SDR. But it's not that expensive. And some of the modern DJI drones actually have those receivers on them, and they plot on the map the location of airplanes. So ArduPilot has a subroutine that if you have an ADS-B receiver on your drone, it will avoid the airplanes. So that's a good possibility. But the problem is that not all manned airplanes are required to have ADS-B. So the point is there's the plethora of different options for collision avoidance between drones and drones and manned aviation. They're not all perfect. No one technology can guarantee collision avoidance. So that's a really important technology area that needs to be worked on. We worked on it some in my lab with the senior design, and we used the remote ID signal from one drone to have the other drone avoid it. And that was a senior design project. Shay now, he was an undergraduate here. He's a graduate student in robotics at Carnegie Mellon. So one of these students, Wen Tao Chen, she's a graduate student at Stanford now. So we have this paper under review doing drone remote ID collision avoidance. So there are lots of opportunities for research in that area to demonstrate technology. But as I've mentioned, technology is only part of the way to get drones integrated in the airspace. It's only one part of the equation. Okay. Now, the last, I think, frontier is what I would call cloud-based command and control. So we talked about Mavlink last lecture, and Mavlink allows an internet-connected drone to be controlled over the internet. Mavlink is the language. So what you're using in my class on the bench is you have Mavlink is the language between the laptop and the drone over the USB cable. And once you get your drones on the internet, which, how many of you got the ESP32 to work already? Raise your hand. None?
Which?
ESP32 drone bridge. Okay, well, you will. That's your milestone. It's pretty easy. It's 4 wires to solder. It's one of the easiest things you've done all quarter. and you log into your drone as a Wi-Fi hotspot like we demonstrated with Shane last lecture. So that's also Mavlink. But once you have a Wi-Fi hotspot, the drone has an IP address. You don't need to be sitting in the same physical location. In fact, you can be anywhere on the other side of the world. And that's what we did to set the Guinness record with some students. I had a pilot on the other side of the world, and he flew the drone that was here, and he flew it by connecting over the internet and sending Mavlink traffic. Now that's illegal without a waiver. I did not have a waiver, so we did it in the drone cage, but it was a bit difficult to keep GPS lock in the drone cage. But if you want to do that outside the drone cage, the FAA has said you cannot do that without a waiver, and you can get a waiver. That's called, but that's why they're doing the beyond visual line of sight rules, so that not everybody needs a waiver. And to get a waiver, it's just like, okay, you guys have been in the youth, and girls, or men and women have been in the UC system for however 4 years. How many of you have gotten rules waived in your career in the UC? I'm guessing half. No? Okay. Well, I've seen a lot of rules waived in the UC system. So it's possible. It's the same thing with the FAA. You can get a waiver for FAA rules. However, you need a lot of work. You really need to convince them that what you're doing is safe, and they're very conservative. And beyond visual line of sight was one of the hardest waivers to get. And also drone swarms was a hard waiver to get. So I didn't have the time. I just said, okay, we'll do it in the cage. But the other point is that now you can have the pilot in one place and the drone in one place, but you don't even need the computer to be near the pilot or the drone. The computer can be in the cloud. So I had a senior design team do this, and there's a few startup companies that have been working on it also. So we did with one team of 6 what startup companies took $10 million to do. And ours is open source. You're welcome to use it. It's on GitHub. And it's called Cloud Station. And normally senior design is 3, so I convinced QB Dang to let me have 6. And they wrote it. And basically, there's a cloud-based computer that's sending Mavlink traffic to the drone, and there's a pilot that logs into the cloud-based computer. Now, what I asked them to do is, instead of Mission Planner, use a website. So the students built a website that was hosted on a cloud-based computer, and the drone pilot just had to log into the website. Here's a picture of the website. So you don't even need a Windows, Mac, or Linux. All that goes away. You just have a web browser or a tablet. So you log into the website that's hosted in the cloud. The cloud computer connects to the drone, and then you can fly the drone remotely. So you're welcome to try that. And these are the pilots in France that did it. There was also some students, and they were really happy. So that's the cloud-based command and control. And I think that's also a possible avenue for future drone technology development. And if it's all going to be unmanned, and if they're going to be beyond visual line of sight, then that seems to be the way the industry is going to go. One more theory slide about AI. Next week we'll talk more about AI, but I decided just to keep the internet to be the theme of this talk. But couldn't resist telling you about my latest project, which is a completely AI written ground control station that has a web-based interface rather than installing a local computer. And this is the same thing that my undergrads wrote. It took them a year. I did in 2 weeks with AI, and I didn't write a single line of code. And there's a picture, and I have a lot of really nice features that I really like. For example, I told you about the heartbeat, that the Mavlink emits a heartbeat. Now, you'll see it when you're flying out at the arc. So if you disconnect, you don't know, actually. Because you've seen that we did this yesterday. A student was trying to get the drone to connect with the Wi-Fi, and they had Mission Planner, and it disconnected, but they didn't know. They didn't know. They had no way of knowing. You want to know. So Mission Planner has a feature, which I'm not exactly sure how to enable it, but I can find out. I just forgot off the top of my head, where if it doesn't get a heartbeat for 10 seconds, it'll tell you, no heartbeat received for 10 seconds. Warning, no heartbeat received for 10 seconds. That's a long time. So what I did is told the AI I would like a heartbeat that beats, first of all, so there's a little heart here that beats. And I wanted it to beep like a hospital, like if you go to the hospital, like doot, 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 like doot, doot, doot. So it does. So if it goes bleep, beep, if you want, I can demo it for you at the ARC, or you can demo it yourself because it's on GitHub. And one other nice thing about AI is it gives you really nice tutorial and install instructions. So there's two Peter Burke install scripts that you're going to get from me. One is pre-AI, one is post-AI. So all the stuff last year is pre-AI and it's not as user-friendly. And you'll see all the post-AI stuff. It's really user-friendly and it's really easy to follow the directions. So this one is very user-friendly. I invite you to try it and you can install it on any computer. Well, Linux. I didn't set it up for Mac or Windows. But you can create a Cloud Linux instance, and we're going to do a Cloud Linux instance on Tuesday in real time. But how many of you are Amazon Prime members? You all have free cloud, uh, Amazon Prime cloud service for a year for their low-end servers. So you can all get a free Linux machine running in the cloud for a year. After that, they start charging for it. And even then, it's very inexpensive. It's like a few cents an hour or a few dollars a month for the low-end ones. So, but wait, there's more. I also wrote this so you can host it on the Raspberry Pi that's on your drone. So if you put the Raspberry Pi on your drone, which we're going to do next week, you can install this ground control station on the Raspberry Pi that's on the drone, and then you have a flying website in the sky. So you don't need Mission Planner at all anymore. No, it's not, it's in alpha form. Okay, so be very careful. Like be ready to disarm. But this is another example of cloud-based internet control of drones. And the cloud-based computer can be anywhere in the world. And you're welcome to try it. And it's an example of AI. So this is AI for coding. How many of you have vibe coded? Raise your hand if you've vibe coded. But yeah, it should be a lot of you. So it's really useful, but it's not always reliable. So this, as an aside on AI, this is not an AI class, but as an aside on this, well, let me ask you people, what's the longest program, what's the biggest number of lines of code that you vibe coded? 30? Okay. 800? 300? 800. Why didn't you do more?
I was done.
You were done. Well, the AI can't. It doesn't have enough memory. It doesn't have the context window can't handle. So a really important topic in AI is how to expand it so you can write more than 1,000 or 10,000 lines of code. This, I think, is about 10,000 lines of code. And once you get beyond that, the AI starts forgetting things and it can't tell where everything is wired up. Yes.
It really helps if you modularize that function with designated inputs and outputs, and that will like shrink the one.
Modularize it. You're hired. Yeah. So I did not do that in this case. I had one agent. And recently, Anthropic has come out with the way to have subagents through Claude. And that's what you're saying. That's partly what you're saying, is to have a master agent called a main agent called subagents, subagents called sub-subagents. And that, I think, is the way of the future for AI. But it doesn't exist. So AI coding is not at the moment my primary forte and field of expertise, but the field is not able to generate large projects in one shot or even a few shots. I'm thinking someday you could write all of Linux with AI. You could write all of Windows with AI. You could write all of Mission Planner with AI. But each one of those is over 1 million lines of code. So at the moment, there's no way to replace all that with AI. So this is a very bare bones version of Mission Planner. It's got fly to, it's got mode change, but doesn't have all the features that Mission Planner has. But it was a fun exercise. And like I said, it took me 2 weeks, what it took undergrads, probably 3 to 6 months of person time. So it really was a time saver. So yeah, I'm not anti-AI in education at all. I would encourage you to exploit it to your ability. It's a tool that you can be very useful. This is an example of that. Okay, so next lecture, oh, we still have the announcements. Okay, so next lecture where I'm going to, in front of your very own eyes, create and fly a virtual drone from scratch. I'm going to demo control of a real drone over the internet in my office. And then I'm going to demo, and I'll talk you through how to do that with the tutorials that we have on the website and give you a demo. And then I'm also going to demo some remote ID receivers